Hey guys, here we are to talk about polyatomic ions and writing formulas today. This is the third lesson in our unit about ionic compounds. So here's a chart of polyatomic ions. Take a close look at these. What we've been doing so far were called binary compounds, binary meaning two. So we've always had one metal and one nonmetal. Binary, 1 and 1 is 2. So now we're going to get into polyatomic ions. Polyatomic means more than one. So look at these. All these ions have more than one element, poly, more than one. Notice how they all have negative charges except for ammonium in the bottom right. That's one of the few that has a positive charge. But most of these will act as our nonmetals because they're all negative. So we're going to hook them up with something positive, the metals, and these are going to be our nonmetals. So let's take a look at how this works. So before, when we were doing binary compounds, we had compounds such as this. Lithium chloride. One metal, one nonmetal. We had some that consisted of transition metals. Iron oxide. Iron 3 oxide. Okay, we had one metal, we had one nonmetal. So now when we're going to do these polyatomics, let's take a sulfate, for example. SO4 with a -2 charge is called sulfate. So we can bind this to any metal, let's say lithium, which has a +1 charge. All right, so we're just going to treat this as one entire unit. The S and the O's, they're going to stay together. They're bound molecules. So just treat this as one giant thing. I'll put parentheses around it just so you kind of remember for now. Okay, so when we're going to bind these together, we're just going to take the lithium, we're going to take the sulfate, put them next to each other, and then we're going to crisscross the charges like we did before. The 2 from the sulfate is going to cross over. We're going to put it after the lithium, and because the lithium has a 1, we're going to cross that over, and we would put it outside here, but we don't write 1s, so we're done. This would be lithium sulfate. Okay, let's take a look at another one. Let's say we have some magnesium that has a +2 charge, and let's take some phosphate. If we look on our polyatomic chart, we could find phosphate. It's a PO4 with a -3 charge. So we're just going to put them together, just like we did before. Mg, PO4, and simply crisscross the charges. This 3 from the phosphate is going to cross over. We'll put it after the magnesium. And then we definitely need parentheses here. Usually parentheses are only used if there's more than one of these. So this 2 is going to cross and go on the outside here. Okay, again, don't mess with anything inside here. The PO4, it's going to stay the same. It's never going to change for right now. This would be called magnesium phosphate. Because magnesium is not a transition metal, we do not need any Roman numerals. All right, here's one using a transition metal. Let's say we had an iron that has a +3 charge, and let's try a, let's use a sulfate again. I like sulfate. -2. We'll put them together, put the iron here, put the sulfate next to it, and let's crisscross. This 2 from the sulfate is going to cross over to here, put it after the iron, and then let's put parentheses around the sulfate, and the 3 from this iron is going to crisscross over to here. Now, because this iron is a +3 iron, we're going to write it as iron 3 sulfate. Remember, the Roman numeral represents the charge of our transition metal. This is only for transition metals, just like the other ones that we did in the last lesson. Okay, polyatomic ions can be a little confusing because sometimes you can't recognize if it's a polyatomic or a binary compound. So let's look at a couple examples here. Let's say we have calcium phosphide. This would be calcium phosphide. Remember, the phosphorus, this comes from a phosphorus, and we always end our nonmetals with an IDE, calcium phosphide. So let's look at calcium phosphate. That would be Ca3PO4, because the PO4 is the phosphate ion, and we'll cross that 2 over there. This is calcium phosphate. All right, refer to your formula sheet for all these polyatomic ions and their names and their charges. You definitely need to have that handy to be able to do these problems. So just keep in mind that if it's a single nonmetal phosphorus, it ends in IDE. If you see anything that's not IDE, eights, ites, those are your polyatomics, and you have to find those on your formula sheet. That's how you tell the difference. Let's look at these two ionic compounds. They both contain potassium, potassium, potassium. But what's the NO3? It has more than one element. This is a polyatomic. So we're going to have to refer to our formula sheet. NO3s are called nitrate. This is potassium nitrate. This one here is just a single element, so we refer to our periodic table. Well, this is nitrogen, which just becomes nitride. So now let's take a look at how we write formulas from the names of compounds. Before we did the opposite. We had a formula and we had to write the name. But now we're going to do the opposite. So the way to do this is very easy. I think this is easier than the other way. So all you do is you write your elements first. We have aluminum, so write Al, and then we write the O for the oxygen. Okay, so now we have to account for the ratios that these guys are going to form when they make a compound. So you do that by the crisscross trick. So aluminums are +3, oxygens are -2, so we crisscross those. This 3 goes down on the other side of the oxygen, and this 2 comes down and goes on the other side of the aluminum. This is aluminum oxide. It's just using the crisscross trick. Let's take a look at another one. How about lithium chloride? Okay, so just write the symbols, lithium, chlorine. Okay, lithium is a +1 charge, chlorine's a -1 charge. You crisscross them, but they're both 1, so you're done. This is your formula unit, LiCl, lithium chloride. Okay, how about this one? Calcium nitride. Write the symbols, calcium, nitrogen, nitride is nitrogen. All right, let's think about our charges. Calciums are +2, nitrogens are -3. Crisscross. The 2 from the calcium will go outside of the nitrogen, and the 3 from the nitride comes over here. There we go. This is our formula unit. How about one with the transition metal? We know this is a transition metal because we know iron's a transition metal, but you could also tell because it's giving you the Roman numerals. This is the charge on that iron. So let's start off the same way as we just did. Write the symbols, Fe, sulfide is S. All right, now we have to take care of the charges. This is a +3 because that's what the Roman numeral 3 stands for, the charge on the iron. Sulfur is a -2 charge. Crisscross. We'll take the 2. It goes outside of this iron. We'll take the 3 from the iron, put it on outside of the sulfur. There you go. Fe2S3, iron 3 sulfide. How about this one? This is iron 3 sulfate. Sulfate. Where are you going to find something with an ATE at the end of it? On your formula sheet. This is a polyatomic. It's not sulfur, it's sulfate. SO4 with a -2 charge. I want to put it right up there. Okay, sulfide would be an S. This is sulfate. So we'll write our iron. Okay, again, this one is a +3. So let's crisscross. Let's do this 2 here from the sulfate. Cross it over. Put it after the iron. Now this 3 is going to go on the outside of the sulfate. Put parentheses and put that 3 there. All right, don't stick the 3 inside here or mess with these at all. It just goes right on the outside. This is iron 3 sulfate. Here's another one with a transition metal and a polyatomic. We have our copper. Copper is Cu. It has a +2 charge. We know that because of the Roman numeral. I'm just going to put it up here to keep it out of the way. And nitrate, polyatomic, ATE. You should be thinking, formula sheet. This is not nitrogen, which would be nitride. This is nitrate. Nitrate is NO3. That has a -1 charge. Let's crisscross. The 2 from the copper is going to go on the outside of the nitrate. We'll put it out here. And the 1 here from the nitrate is going to cross here, but again, we don't write 1s. Here we go. Copper to nitrate. That's how we write these. All right, that finishes up our unit on ionic bonding. I hope you're excited. I hope you learned something.